Before we formally talk about Learning Objectives 8.2 D and E, I want to talk about the four-step process for a confidence interval. So we're going to go through the state, plan, do, and conclude portion. And I'm going to tell you the AP board isn't looking for these words as state, plan, do, and conclude necessarily. They're just looking for these components somewhere in your analysis. So for the state part, when you're asked to construct a confidence interval, what you actually want to do is talk about what parameter to estimate and at what confidence level. So if we're going to estimate the parameter is P at a 95% confidence level, we'll talk about that and define it. In the plan, we are going to identify the inference method that we used. So as of now, our inference method is a one sample Z interval for proportions. And then we'll check the conditions of random independence and normalcy. In the do part, if the conditions are met, just go ahead and perform the calculations. Remember, in this case, you can show your work for that calc. And then the last thing, and really the most important, is the conclusion. You must interpret the interval in context of the problem. If you just leave the numerical answer and you don't do this part, your free response question, which could be a 4, would automatically be docked to a 3. Now, don't forget to reference the handout I gave you about all of the various procedures you can use for confidence intervals and tests related to chapters 8 through 12. You will find this particular one on the handout. It is called, for one sample proportion, the confidence interval for proportion P. So I recommend that you do reference this sheet as we start learning about the various confidence intervals and tests we can do in the next chapters from 8 through 12. So let me show you how to do this one here with all the steps. According to the article in the San Gabriel Valley Tribune, most people are kissing the right way. That is, according to the study, the majority of couples tilt their heads to the right when kissing. In a study, researchers observed a random sample of 124 kissing couples in various public places, and they found that 83 of 124 kissed the right way and tilt to the right. They want us to construct a 95% confidence interval for the proportion of those that tilt their head and kiss the right way. Okay, the state part. What is our parameter that we want to analyze, and what confidence level are we using? So what I'm going to say here is we want to estimate P, which is the true proportion of couples that tilt their head to the right when kissing, at a 95% confidence level. Okay, so let's go ahead and do the plan. Now, the method we're going to use, this is the first formal confidence interval we've had, so it's the only one we can talk about. I will tell you, as we go from chapters 8 all the way to 12, you need to name the method in your plan of what you're going to do. And this is all what 8 through 12 are about. They're very, very similar in how we do it. What happens is we choose a different method. So for this one, we did a 1 sample, not a 2. So I say that. It's a Z interval for the P, or the proportion. If you state this, you'll get full credit. Now, if you don't state this, you actually have to state the formula for it. Trust me, this is going to be a lot easier to do. Okay, let's check the conditions. Randomness. Was it random? In this case, we have, for our randomness, that the researchers observed a random sample of couples, which it states above, so we're good. Independence. The number of couples in the population, we had 124 in our sample. If there's more than 1,240 couples in our population, we're fine. Normalcy, our success and failure both greater than or equal to 10. In this case, for the normal condition, our sample size times 83 over 124 is 83, which is good. 1 minus that proportion is going to be 41, so normalcy is met on that. Now, for the do portion, I technically like to have this written somewhere on my paper, so maybe you already do. I like to state that the sample in this case was 124. The confidence level we're dealing with is 95%. P hat, if we change our fraction to a decimal, is actually 0.669. Now, I'm going to show you this one, really how to do it on a calculator. Let me just show you by hand, though. If we wrote down the formula for it, what we'd have to do is, here's the standard formula. And when I said earlier, when you talk about the method, if you say it's a 1 sample Z interval for P, that covers you versus having to actually write this formula down. As we get more and more tests, this is going to be easier to say the words versus to remember these formulas. If we just pop the information in, this is our p hat, 95% confidence interval. Again, we're going to do inverse norm for that. Be careful, we want 97.5% of the curve at 0 and 1. It's 1.96. You're going to start to get really used to 1.96 for 95%, so it never does change. And then here is the standard error for p hat if we fill it in. If we simplify this formula, we're going to get that the actual confidence interval is right here. Now, if I wanted to write down the standard error of the p hat and the critical value, I could. I already found those. This standard error, folks, is just this number right here. The z critical value we found up here was the 1.96. I don't technically have to have that written down, but I did. Now, again, as we go through chapters 8 through 12, you're going to want to know the calculator shortcuts for this stuff. So what you want to do is go to the stat button in your calculator. Now, once you hit that button, it's going to default to edit. Scroll over to tests. This is the button you're going to use for the rest of the book. We want to scroll down and find the 1 prop z interval. You're going to have to scroll away as it's letter A. So this is 1 proportion a z interval. If you click on this, it's going to ask you for this information. So it wants to know your X number of successes over N, how many trials you did. So we had 83 successes over 124. What confidence level do I want? I want 95% confidence. If you do that and hit enter, it is actually going to compute for you the confidence interval. So what it gives us is this. And this right here is the exact confidence interval. Notice my p hat is right here, which I've already stated. And the sample size is kind of what I stated too. I personally like to write all this down on my piece of paper. And this is acceptable ways to find the confidence interval on the AP exam. If you use the calculator method, you have to state these key components, the 95% level, show the N, show the p hat, and show your conditions. Okay, now all we have to do is wrap it up with the conclusion. So I'm going to interpret it and say this, that we are 95% confident that the interval from 0.586 to 0.572 captures the true proportion of couples that tilt their heads to the right when kissing. Okay, I have to caution you on some things. I think this is great advice from the AP board. It says here, if students include the confidence interval calculations using the formula, so they do it by hand, and they use their calculator, and if the answers do not agree, this is considered to be a parallel solution. One of these is probably the correct answer. If you do that, you will get absolutely no credit for either of the correct answers. So go with one or the other. Do not show both if they're different answers. This here I also mentioned as a tip. If you use your calculator to compute the confidence interval, which I recommend you do, it's going to really save you some heartache and some memory of things. You only get credit if the answer is correct. Instead, what they're going to recommend is show the calculation in the appropriate formula. Now, as long as you say, for this last one, it's a 1 sample z interval for p, or your proportions, and you show your various statistics, you should be fine. Just be incredibly careful when you write the confidence interval down from your calculator to your paper not to make a typo, because if it is a manual typo, you will get it wrong unless you show the actual formula. Some common misconceptions and things that should be clarified are this. When we talk about the parameter, keep this in mind. The parameters for the population, so there's only one true value of a parameter. It's never going to change. Your p hat, or your estimate of the population, could change based on all your samples. Also realize you don't know the true value of the parameter. If we knew it, we would not need to do a confidence interval. We only use a confidence interval to estimate the value of the parameter. So if we knew it, we wouldn't do it. Third thing, never use p hat when referring to the value of the parameter p. If you're talking about the population parameter, don't put a hat on it because they're going to mark you wrong. All right, now what about interpreting a confidence interval? Here's 3 key things to keep in mind. A confidence interval makes a statement about the true population proportion, and your interpretation of this interval should be about the population proportion. So it's how confident we are that the true population proportion is in that interval, not that a sample proportion is in that interval. So be very careful about that. Second thing, keep your interpretation to what you know. Don't claim too much. The more wordy you get and you start to get fluffy, you're going to say something you shouldn't, so don't. Just be short and sweet and say exactly the definition you should and stop. Third, sample statistics vary with each sample. Not every interval you compute will capture the true population proportion. Your interpretation of the confidence interval should reflect how confident you are that your interval has managed to capture the true value. Remember, your confidence is in the method used to produce the actual interval. So let's do the formal part of our notes in 8.2 D and E here. We first want to determine the sample size required to obtain a level of confidence of our interval for a population with a specified margin of error. And then we want to understand how that margin of error of the confidence interval changes with the sample size. So when you have to choose the sample size for desired margin of error, keep in mind that this right here is the formula for the entire interval. Remember, the margin of error is actually the critical value times the standard deviation. So that's what we're looking at for this example. Now this formula here is kind of on the AP formula sheet. If you forget what the standard error is of the proportion for your confidence interval, it's going to be right here where it says sample proportion. Now this should have the p hats on it for our actual margin of error calculation there. So just be cautious on that. So in this example, suppose you wanted to estimate P, which is the true proportion of students at your school that have a TAT2. We want to be 95% confidence. And I want my margin of error to be no more than 10%. So determine how many students should be surveyed for my estimate to have that confidence and that margin of error. So now remember, the formula for that margin of error is going to be our z critical value times the square root of P times 1 minus P over n. So we want to make sure that this is no more than 10%. Now as you read this, the only thing that we know is that if this is our margin of error, so I'm going to call this margin of error. If that's margin of error, I know that that margin of error here should be the 10%. The 95% confidence I know is a critical value. I'm used to finding that as 1.96. The sample size is what I want to find, so clearly the sample size here is blank. What do I put in for P? Well, I don't know anything about that, so you have to make an assumption or an estimation. And here's what we're going to say. Since we don't have any previous knowledge of our proportion of students with a TAT2, we're going to use P hat as being 50% to estimate the sample size needed. Every now and then I have seen multiple choice questions from the AP board where you have to make this assumption. So if you read the problem and you're like, I can't figure out the proportion, it's because they want you to assume it's 50%. So let's put that information in here, and here's what it's going to look like. So we're just setting this up. Just like I said, our critical value are 50%. I don't know this, and I know that. Now I'm going to show you what they've done to simplify this formula. Because if algebra is not your strong suit, you might be a little tricky with this. Let me show you what they've done. They actually first came in, and they squared this side, and they squared this side to get rid of the square root. Well, in doing that, this became 0.10 squared. This square root symbol technically is going to go away, right? But this squared has to go over here, so it technically moves over to there. And I'm just going to kind of get rid of it there. So now what you're going to see that they've done is they're going to come on in here, and they are going to basically cross multiply. So they're going to move the n up, and they're going to move the 0.10 squared down. So what you see here when the n comes up, it's over here. You're going to see this 0.10 squared come down, and you see that grouped here. And then remember, the square root was removed, so we have that. If you simplify this calculation, you're going to end up seeing that the sample size for this should be greater than or equal to 96.04. Now, if this was a multiple choice question, and again, you were struggling with the solving, if you have this component, go ahead and just plug in n from the multiple choice and see what would work. Can we conclude from this? So we need to survey at least basically 97 students because we need at least a 0.04 student to estimate the true proportion of students with a tattoo with 95% confidence and a margin of error of at most 10%. And again, if you're struggling with solving of this at any nature, please come and see me and I'll help you. Let's wrap it up with checking your understanding. In this scenario, a company's prior year survey, 80% of the customers surveyed said they were satisfied or very satisfied. Use this value to guess for the standard deviation to find the sample size needed for the margin of error of 3% at a 95% confidence interval. Okay, great, 95% confidence, we know, 1.96. Our margin of error is going to be 3%, and our p-hat is going to be at 80%. So we're going to put this in to the formula that they had before. Let me show you this. We're going to put it in like that. So just the initial setup. This is our margin of error calculation. Everything is put in there. To go ahead and solve this, I'm just going to show you the exact same way they did in the last example. And then I will work number 2 out here in more detail for the algebra. If you do this and you solve it, you're going to get that the sample size should be greater than 682. So we're talking 683 people is what you need. Okay, what if we have the same scenario, but now they don't want 95% confidence, they want 99% confidence? The only difference is I'd have to compute a new critical value. And at 99% confidence, for this one, think about the critical value. I'm going to display this for you. How did they get that critical value? They're doing an inverse norm of 99, 5, and a 0 and a 1. That's where the 2.567 comes from. And just plug this in like that. Let me show you their actual solution to it. The required size, if you want to be more confident, instead of 95, you want to go 99, you're going to have to sample 1,179 people. Okay, let me help you with solving the algebra on here if you're struggling with it. I'm going to show you a different method. What I personally would maybe do is I'm going to move the 2.567 over to the other side. So I'm going to divide by that on both sides. So it's now over here. So hopefully you can see, I'm going to cross this off, this is gone. So to remove this square root, I'm going to square both sides. So if I square this, I now square that. So now I'm going to go on in and I'm going to do 0.8 times 0.2, and that's going to be a 0.16 over n, and I'm going to do less than or equal to. I'm just going to go ahead and put this in the calculator, do 0.03 divided by that and square the answer. And I'm going to get, it's going to be 0.001356. Okay, now to solve for n, this is just a fraction set equal to a fraction. I'm going to cross multiply. I'm going to bring that up and bring this one down. So therefore I can do the 0.16 and I'm going to divide it by my answer on the other side. And when I do that, I'm going to get that n is greater than or equal to 1179, which is what they got to. So hopefully that helps you solving for the appropriate sample size.